Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel, Kevin Compass, and we have a special guest, Andre Patenaude from Emerson Technologies. What's going on tonight, Andre?
Hey, Brett, Kevin, nice to be here. Thanks a lot. Appreciate the opportunity to be able to talk to you guys. We're
Um,
talking at HR and talking about all kinds of cool CO2 stuff. So we thought we'd get back together and shoot the shit.
yeah, absolutely, 100%, man. Yeah, so, Andre, how's your week going?
Good, good. It's been a busy week and ready for next week. Off to California for some training. So we're doing some end user training next week. End user and consultants and OEMs, I guess. That's the bulk of it. Then the week after, I guess we'll see you at the NASRC technician training.
Yeah, Kevin,
Right.
are you going to that?
No,
You're not going?
no.
Damn it. I was all excited, thought you were gonna be there too. So if not that Kevin's been tired of me talking about this, but out in California, out in Irwindale, they're having the Natural Refrigerant Summit put on by the North American Sustainable Refrigerant Council, going on the week of April 4th to the 6th. It's jam packed with anyone from Emerson's going to be there, Danfoss is going to be there, Corell's going to be there, Bitzer's going to be there. Man, the list just goes on of everyone that's going to be out there. It's going to be freaking amazing.
Zeros, a whole bunch of them.
Yeah, Zero Zone, Hussman. It was actually real cool. So I worked with Danielle Wright, and she called me. She's like, "Who do you think would be good to get out there?" And I gave her. We were on the phone for damn near 2 hours, and I'm just like giving her the laundry list of people who I thought that we should have out there. And man, she came through. I don't think other than I think Gutner and BAC were the only people. But I don't even think we could fit any more trading in there if we could. I mean, it's literally jam packed.
There's a ton of sessions. I think there's over 70 in 3 days or something. There's a lot going on.
Yeah. So if the registration is still open, so just Google the North American Sustainable Refrigerant Council. Listen, I've posted a whole bunch on LinkedIn and on the Facebook group as far as advanced refrigeration as well as my personal. So I mean, registration is still open for technicians. It's free to go. You
Yeah.
just got to convince your boss man of how much it's gonna help you out. You know, Kev, what do you
Yeah.
got going on this week? Oh, sorry, what's that?
No, go ahead.
Kev, what do you got going on this week?
Oh, I'm just running service.
Oh, really?
Just yeah, kind of slow. So it's like boring service. Like no disasters, nothing fun. Like fan motors out, and it's just like I'm beating my head against the wall. It's like it is. I have never been so bored this week already.
You know what's gonna happen next week
Okay.
now, right?
Well, I would take a good disaster. I would take a good disaster, good shit show. You know, something something bad, like just you know something besides just fan motors and, you know, de-icing a case. Like
The
I
regular,
that kills me.
the regular mundane stuff, right?
Oh yeah,
You
like
got
the
3 more
minimum
days.
What's that, Andre?
You got 3 more days.
the stuff that some guys like look forward to,
Waiting.
just the fan motor or something easy. Like, yeah, at the end of the day, I'll take that. But like, oh, all day long, that is just the most boring day ever.
And then tomorrow he's gonna be like, "Oh man, today fucking sucked. I don't even want to come in. I was out all night. I had an explosion on." So,
I should have a bunch of jobs, but we have no parts to do anything. So,
but there's a part shortage. Since when?
but since ever, like or cases just don't show up to jobs.
That's awesome. That's awesome. I'm home this week. I'm actually teaching that the class that I've been developing. This is our first week doing it. I don't know why, man. I was so nervous today. Like usually teaching, like I have no problem just talking, chewing the fat or whatever. But I don't know if it was the fact that I developed it. Was the fact that I was so nervous about it. Like, cause I've been going over this thing for weeks, making sure, and then like all of a sudden I'll realize, oh, I didn't put this down. Oh, I didn't put this down. This is good because like the guys are getting involved in the conversation and as they're talking, I'm like, hold on. So like someone brought up the Bitzer unloading line. So I was like, all right, well, next time I'm going to throw that in there. So it's good. I'm getting feedback of what the guys are seeing out there and, being able to, cross off some of the stuff that I wrote down, maybe the stuff I went too far in depth. Like I covered the Sky Cool system, because they're going to be seeing it, right? We want to make sure, the part of this whole part of the training was to make sure that I'm covering stuff that usually isn't covered in a regular conventional intro to CO2 training. So, but tonight we have Andre on, and we're gonna just, like I said, chew the fat about some refrigeration, about some CO2. And Andre, what else? What else you got going on in your worldly corner? What are you working on?
Oh, working on some white papers, working on, well, the presentation for NASRC. You talked about a new presentation. And Kevin, I don't know if you know this, but we have a transcript called Mobile Trainer. I've been working with Brett on. Have you ever heard of it?
Oh, yeah, I get to hear about it at least 15 times a week. Yeah, that's only talk about conversation with everybody about that, about how he's mobile CO2 trainer. But you know what? I had one first.
Man,
I had- We had one 2 years. We had one 2 years ago at our union hall that
I,
you
wa-
guys did.
I wasn't in charge of training at that point, so now I'm excited. I'm sorry.
I'm pretty sure we had the one of the first ones you guys made. It was an LMP Emerson.
yeah,
It's at our union hall, like very, very first version.
yeah, it had two sections, right? It had a pump skid section, and then the refrigeration part. And they were plumbed together by flex hoses. That was the original version.
So
That the one you're
ours
talking
is after that. So ours was one skid. It had two evaporators on it, a little boiler, um, little mini Copeland compressors with drives.
Yep, that's cool.
Andre just brought
Yeah.
that up because he knew it was going to irritate you.
Well, you're talking about that because I've been working on a new presentation. Was taking that trainer and blowing up using the PNID and kind of walking through each section of the PNID and then taking a picture so we can associate the PNID with the actual unit. And after the training course is over, then the guys can go around you and kind of identify all the parts and direction, where the heat exchangers are and so on and so forth. So that was a new one kind of putting together and get ready for next week. So that'll be a new one.
Cool. I mean, you said you had something going on in Ohio. What do you got going on there?
Yeah, I was in Ohio. Well, Ohio is actually where the trainer was. So I was doing some work with the trainer. So I go to Ohio all the time because it's about 4.5 hours from here. And I report directly to Sydney, Ohio. So there's always something going on there, whether it's a customer visit, colleague meetings, or, doing some training or whatever the case may be. So there's always something going on, whether at the Innovation Center at Dayton or at the head office in Sydney.
Gotcha.
Yeah, lots going on.
Awesome. Well, Kev, you want to start in because you had some questions for Andre that you wanted to, try to get some answers for. So let's get on it.
So I wanted to start off talking about gas cooler control. 'Cause, we started talking about with you and Waylon about all this and about a lot of the stuff we see. Gas cooler control. It seems like every OEM we're failing with the gas cooler control. It's just all over the place, and it seems to be nobody has a clear cut answer of how to make this work right. But it seems like the answer of everybody is using drop like temp, and the way they're controlling the fans, it just seems like it's all over the place, and it just has such poor control. I mean, especially when it's cold out. When it's warm out, it's okay, decent, but I mean, it just seems like we're having so many problems with maintaining good flash tank pressures and good or discharge pressures and drop leg pressures with using drop leg temp. It's just all over the place, and it seems like it's fighting the high pressure valves also.
Is that because you're going really lower? How low of the head are you running? Typically, what do they set them up to?
Usually 45 to 50.
Oh, 45 to 50. Okay.
Yeah, 45 to 50 drop leg temp.
Okay. Because we had a job about a year ago where the customer kept wanting to get 45 to 50 degrees. And this is a process job instead of a supermarket job. a little bit different because the system would cycle off once in a while. But we found that exactly what you were saying. When it got below 60 degrees, then things started losing control. And we dial into, I know Brent Cheshire, myself, and Eben and Mike Hill. We look at the logs and try to understand what's going on because you've got compressor cycling. You talked about you've got your fans, your variable fan speed, and then you got the high pressure in the bypass valve, and all these things are not in balance. And we couldn't seem to stabilize the system when it got so cold. And increasing that minimum drop leg to 60 degrees seemed to kind of settle things out. And I've had this conversation with Wyman as well about that. And when we did our climate study, because he's done a lot of these jobs in low ambient, as well as, of course, all around the world. And his minimum set point that he recommends is around 60 degrees because he finds that the gas cooler becomes so bloody efficient in those low ambients that you reach the pinch point real quick. And then so your ambient reaches condensing so fast that everything tries to equalize or balance itself out and it can't. So he finds that changing that set point to a minimum 60 degrees seems to really settle things out. So we actually did that at this job and things did settle out at that point. And I was talking also to Alain Mulgay, who's my colleague in Quebec, our contractor business development manager, who's been also doing CO2 for, supporting CO2 jobs since 2014. And I asked him that same question. That's exactly what he had mentioned too. You don't like to go below 60 ambient, not ambient, 60 drop lake temperature, which is about 50-degree ambient or something around that, right? Depending on the TD on that gas cooler. And it seems to really stabilize operation. And like I said, with our supermarket lab that we're getting up and running and doing some baseline, we're going to be able to really understand the real nature of all of those things too. We're going to have a sandbox so we could do it. We could do the 60, we could do the 40, we could do it even lower if we want to, and understand what's going on in that gas cooler, understand, where that ambient hits the condensing temperature, what happens in the rest of the gas cooler for fans and everything else to try to balance itself. So I probably didn't answer your question that clearly, but from, you know, talking to guys like Vinen and others, that seems to have been a fix.
Yeah, I'm seeing a lot of problems too, like in like colder climates. When I mean these racks run fine when it's like 60, 70 degrees out.
Mhm.
But as soon as we start getting into like, the 20s and 10s, the way that most of these gas cooler fan strategies are set up is very few people are cycling the fans. It's usually just all of them on or all of them off. Like on a variable speed, it's usually all like 4 or 5 fans ramping up at the same time and then ramping down together at the same time, which seems to be causing, you know, a lot of hunting, obviously.
Sure. Sure.
I know a lot of
And
gas coolers now, they're all mod bus together. So I don't even know if it's feasible. Like typically if it's controlled with like a 0 to 10 signal, like what Kevin has said that he's done in the past is just use a relay to basically either give it the 10 volts to make it run down 0% on, that one side of the gas cooler. Would it be up, Kevin, would it be a minimum set point on the controller, whatever is controlling the HPV? Where it doesn't have a set point in there where it's actually showing your minimum saturated condensing temperature for that, or am I wrong?
So they have a minimum gas cooler pressure setting in like the 326, and I believe it's also in the iPro. There's a minimum gas cooler pressure to where that HPV valve turns into basically a holdback valve to try to keep the gas cooler pressure up. But I mean that's where you're walking this fine line of pressure and temperature, trying to keep that keep your drop leg temperature up high enough where it's not going to hit that setting, and then also the fan cutout setting and whatever controller you're using. So there still is some pressure control there, but
one of the things that we had recommended, I think we talked about this at AHR, was, and you just mentioned that all the fans ramping up and down at the same time. And this particular job we were talking about, I think they had 10 or 12 fans and they were all doing this. And so we had recommended, you know, breaking them up in banks of two in order to when it gets colder and colder. And then you've got some more variability that you don't have all this volume of air, even at minimum speed when it's 20 degrees Fahrenheit. That's a lot of condensing power there. Whereas splitting them up, I don't think they ever did that, but that was one of the recommendations that we had passed along as well.
Yeah, I mean,
I think
it seems like a really easy thing to do, especially on a new piece of equipment, but like it just seems like none of the manufacturers are going that way. Like
right.
it almost needs to be an industry standard change, like to do that. It's just like everybody's pushing for this, one EC, solution that everything's on and everybody's off.
Yeah. And that doesn't help you in the field when it's 20 degrees outside.
Correct.
Yeah.
I
That's
do
for sure.
know I do know that Emerson is working on basically making the iPro, at least on their settings, like making the inputs for some of the percentages and stuff actually writable. So like you could do some sort of sensor control or whatever, maintaining whatever number to try to, mitigate like the large jumps. So you can have a calculation basically rather than a stagnant set point for some of those things in the iPro controller. I saw some emails go along about that, and I know that they've been working on that. So I don't know if that'll help out your situation, but I agree. I mean, they should be able to bank off those fans. And I just that's something I don't know. I don't know, when they're Modbus together, I don't know if you have that full capability unless your controller itself, has the availability. Okay, let's talk to fan number 1 and 2, and I just want those on. You know what I mean? I just think you'd
Yeah.
be able to have a little bit better control if it's Modbus together, wouldn't you think, Kev?
Well, yeah, I mean, you should. I know they just that Gutner controller that finally interface with the E2. I know it works with the E3, but but yeah, they being able to cycle your fans if the E3 is doing the fan control and just talking and writing to that Gutner controller. I mean, that would be a huge thing to be able to split
Right.
that up, and it'd be a cheaper cost. But I mean, that's all like what if you could read and write to those points.
Yeah, and that's one of the things that we also hope that the lab's going to do is build collaborative meetings and efforts within OEMs. You talked about Gutner and of course others to be able to work through these things together. That'd be good.
Yeah, I mean that seems to be like one of my biggest gripes with CO2 is like they run pretty decent, 70, 80 degree weather and like you struggle a little bit when we go transcritical, but like man, I'm up in Chicago and like we just struggle all winter long in some of these stores with low load. I mean, it's just
Yeah, that's the problem, right? It's not just low ambient; it's low load in the winter.
yep. I mean,
Right.
we do a lot of Aldi stores and like they throw the nightshades down. I mean, there's not very much in an Aldi store and they throw the nightshades down and then boom, all load's gone. Then we're stuck with a compressor that can only go down to 25%. And it's just struggling all night long.
Short cycling, sitting there short cycle, Kev.
Yeah. Like it'll just short cycle. I mean, the only load is basically the, dairy cooler. And if the freezer's at temp, it's pretty much dead in the water. And then the flash tank, which you don't have
Right.
much flash tank load.
No.
Does your flash tank pressure then end up going up high and potentially popping off then because of all the cycling?
No, it usually ends up like just hunting all over the place. So we were kind of messing with some settings and on the 326s. And I mean, it would almost seem like I made a mistake and I fat fingered something and we were watching it run and it actually ended up opening the HPV valve because it thought the subcooling was way higher and it actually kept the rack pretty loaded because I had messed up the minimum or the maximum receiver pressure. I ended up setting it like another 70 pounds higher and it ended up pegging the HPV valve open like another 15-20%. And it actually loaded up the flash tank
Sure.
pressure and then loaded up the rack.
Right. So
So
medium temps. started coming on because of your bypass flash gas was so high. Well, high relative to what it was, and it gave you stability.
Correct. And like looking at that and watching it, this was like it was like 5 degrees outside, super low load in the store. They still had nightshades down, but it was enough to load up the variable speed compressor. It was enough to keep the ECM fans, they were, stable. They maybe came on like 5-10%. But I mean, the compressor was running at like 45 hertz, happy as could be.
I wonder if you would change the set point, like if you had a varying subcooling set point. If that it, 'cause and I don't know this, is the 326 able to communicate to the E2?
I don't think is it
Mhm.
it's it's Modbus, but I don't know that it has an application.
Okay. I'm just wondering because, like, if there was some way to, basically change your subcooling set point, because most of these racks that I've seen, for the most part, are set for about, anywhere from 3 to 5 degrees of subcooling. So I'm wondering if, like, if that rack was, let's just say it's set for 5 degrees of subcooling, basically you change the set point to like something a little bit lower. So like, and when I mean lower, like, instead of 5 degrees of subcooling, go down to like 2 degrees of subcooling, which inherently would open up your HPV, right? And then would basically, get a little bit more load on the flash tank and then kind of resolve that issue, I mean, because you inadvertently found that out when you fat fingered it. So based on that theory, I mean, we could basically, change the subcooling set point, which essentially, like I said, open up the HPV and then get more flow to the tank and load up the rack more.
Yeah, I mean, you're doing that at the sacrifice of energy, but at the same time, it's cheaper than a dumpster.
Well, yeah, there is a bit of an energy penalty there, but there's a system stabilization. I guess you have to look at, cycling on and off versus, getting in rust on and off with these compressors versus keeping some of them running at maybe a lower speed. On that industrial rack I was talking about, I mean, that was their way of basically keeping it running without pumping it down when they had no load, with just a bypass scenario between, gas cooler, flash temp suction, and keeping the compressors from cycling off because they had absolutely no load, for 10 hours. But they didn't want to pump. You can't really. They could pump it, not so much pump it, but shut it down, pump as much as you can in the gas cooler and shut it off and just let it build up. But they were just recycling, keeping it running.
Yeah, the other thing, like, is I've been me and Waylon were talking about this a little bit, is actually bypassing the gas cooler completely in super low ambience and just dumping it straight to the flash tank. I mean, that seems to be a available strategy that would be quite easy to implement.
Yeah, he's done that in a couple of cases. And again, this job, he had recommend that to us as well. And so our supermarket lab has that built in. So had that designed in so we can understand those dynamics when it's super cold out. Just bypass the gas cooler and see what happens, right? You know,
So one of the other things I wanted to talk about is, we had an interesting conversation. Kevin, you brought this up, so I want you to lead it. But basically, you were talking about how sometimes when you're running transcritical mode, like the oil separator on a coalescing doesn't seem to separate as much oil as what it does when it running a little bit lower of a pressure. And we were discussing it with, was it Joe that was with us as well?
Joe's name. Yeah.
Yeah, yeah. So it was Joe, Waylon, and Kevin. And I want to touch on that again because that was, man, that actually was really interesting, and I didn't get to catch all that conversation. So I
Yeah.
just want to hear your thoughts on why you think that would potentially happen, especially with the coalescing.
Yeah. Cause you've experienced that, eh, Kevin?
Yeah, so like I've actually spent a lot of time sitting on a bucket watching this in a rack room. Unfortunately, at 2 o'clock in the morning. It's been a while, but so like every time, like, so we got a ton of TC stores up in Chicago. We have a chain that went into it early on, and they seem to have like a ton of problems, and it's carried over to everything new. is every one of these coalescent filters, when we get above like a 90-degree ambient, like they seem to like cut their efficiency in like half. Like they cannot separate efficiently, and or the oil is getting picked back up out of the bottom of the separator before it drains and taken back out to the system.
Mhm.
So my theory is this, that there's so much velocity in that separator when we're running transcritical that it's that filter element can't separate that fast enough. It can't efficiently separate it because the velocity is too high. And or the oil at the bottom is getting picked up like a tornado and carried right back out the separator.
Yeah. I checked, after we talked about this, I looked into it a little bit more as well. And oil carryover rate is a funny thing. It can range from, depending on operating conditions, from nearly zero to 2%. That's a big delta. And even on some of the calorimeter tests that we've run, talking to our engineers and stuff that actually measure, this is what they do when they qualify compressors. They say, depending on the actual condition, subcritical, transcritical, your oil carryover rate changes. And in some cases, it can get up to, over 1%, pushing even higher, depending on specific conditions. And what happens when that oil carryover rate gets a little bit higher than normal and it hits that coalescent filter, depending on the filter you're using, it may not be able to effectively separate it properly, impinge it, and have it drain off properly. It kind of gets clumped up with those particulates of oil. And now it starts to build pressure drop across the filter. And it was interesting because we did run some tests on different types of filter elements. And the pressure drop could go from 5 pounds across that element on a clean element with a high mass flow down to less than 1 psi. And so it's interesting, depending on the elements you have in the construction, the ability for it to manage the higher oil flow could vary from one rig to another. It was kind of interesting seeing that happen. And so it can make a difference what you use for sure from an oil separator and element perspective.
Yeah, it's usually most of the stores they don't get the sprinkler on the gas cooler. And as soon as you get a sprinkler on the gas cooler, I mean the oil problems like stop within like 10-15 minutes. Like the separator starts efficiently separating. So we've run into this problem where guys just think a sprinkler all the time is the answer, which obviously the gas cooler is not going to last long with the sprinkler on it.
No,
So
that's for sure.
we did solve a lot of this with a lot of gas. We had a lot of oil problems in the beginning, and a lot of it was flash tank tuning. Like most of the flash tanks in these stores had like a 50 to 70 pound delta. And that's generally what I see. Some of them are 90 to 80 pounds, like we're seeing at stores, because like none of them are getting tuned. Like they'll just get installed and they'll have an OEM set point file on there, and then nothing's tuned. So we're seeing these flash tanks be like, 50, 60 pound deltas. They're all over the place. They look like like mountains almost, spiky lines on the flash tank pressure. And the majority of these racks, the oil system is set up where the oil reservoir is draining into the flash tank.
Right.
So it is venting in there. So that is controlling your oil pressure. So what was
Yep.
happening is a lot of these stores we were having problems in the beginning is the medium temp compressors wouldn't get oil when they would call to run or call for oil because the flash tank pressure would be low, and then the oil vessel would be low, and then it was too close to suction. It doesn't have like a 40-pound delta between suction and the oil reservoir. For some reason, it doesn't seem like it feeds. Like in normal compressors, 20 pounds are good, but with CO2, it seems like it needs a little bit more pressure behind it to push that oil in.
Right.
What's the reason
Yeah.
for why? What's the reason for that? Is it because you're trying to make up for the oil carryover, like how easy the miscibility is of the CO2 and the oil? Is that the reason for it? Because I mean, now you have two things that you really have to watch out for. Especially your superheat. Because Kevin, as you stated prior, like at 10 degrees of superheat going back to that compressor, you're going to carry over so much more oil than like on a regular HFO system, right?
Yeah, our medium temps typically last for about 20 degrees superheat. On the low temp is 36, and then becomes pretty important from a miscibility and oil viscosity perspective. But yeah,
Wait a minute, you said the low temp was 36 degrees superheat?
yeah,
Then, like, because all the program I'm seeing for the medium temp superheat for the liquid injection is typically set for in between 36 and 55 degrees of superheat on the suction on the medium temp. Those compressors are supposed to be lower?
minimum minimum of 20 degrees. Actually, it's 18.
Mhm.
It's a 10K or 18 Fahrenheit
Mm.
on the medium temp. That's the minimum, and 36 degree on the low temp.
Huh. Kevin, are you seeing that for the liquid injection program on the racks that you're seeing?
Most of the liquid injection I see, like the liquid injection doesn't kick into the medium temp suction is like 50 degrees. So that
50
would
degrees
be
superheat?
no suction line temperature.
So it'd be about 30
Or
degrees of superheat, it'll kick in.
yeah, yeah, about
Yeah,
about that.
just like an HFC system, I mean, return gas temperature is a direct influence on discharge from 1-to-1 ratio, right? So as long as your discharge temperatures are not out of whack, then that's why return gas temperatures, they can be a little bit higher. Even though we say a minimum of 20, the critical temperature is discharge temperature. So whatever that return gas temperature is to limit the discharge from exceeding its maximum point, then that becomes your maximum return gas temperature. But we have to establish what that minimum superheat is from a dilution perspective.
Gotcha.
Andre, have you seen much so far with the centrifugal oil separators on CO2? I just did my first one with Hill not too long ago.
Yeah, I have not personally. I had a seminar that a gentleman did for our team at the Helix Innovation Center because we're doing some testing there, and we wanted to understand what the dynamics are and the difference between coalescent and the centrifugal. And it seemed for the system size that we were testing, it made a lot of sense. So you had some good luck with it on a smaller capacity system. Is that right?
Yeah, so far we did a test Walmart store where they did a mini Advancer Flex rack, and it was like one of the second or third with it was a Westermeyer centrifugal separator in there. And I started this thing up with basically had the flash tank load and one coil.
Hmm.
And fucking worst case scenario, like probably the lowest load it's gonna have. Thing had never missed a beat, not one oil issue. Always kept a ball floating in it, like zero issues. We got it loaded up. We ended up on ended up being like a 70-degree day there. The last day I was there, thing was running full load. I mean, zero issues. From a serviceability standpoint, it looks to me that seems like a better option than a filtered separator on the CO2 side, just for the fact that as your velocity increases, that separator is going to get more efficient
Hmm.
instead
And it
of
worked well, right?
it worked well at low ambient still because we
Right.
still had an amount of velocity going through there. But I mean, from a serviceability standpoint, I mean, I would think the centrifugals would just kill it in CO2 just for the fact that I mean, when we're moving more oil in the middle of summer, I mean that thing's going to be separating more, or it should be at
Right.
least.
Yeah. Dude, it was just principle. Yeah, that makes sense. Yeah. From the presentation I had, it made a lot of sense as well for what we were looking at.
So you keep talking about this place out in Ohio where you guys are doing the whole training center, this whole training lab or whatever. Do you have on this thing like you keep saying we're testing different things? Does that mean like you have like two or three oil separators on the system and you're selecting on which way that's going through, or like I mean when you're saying I'm as you're talking I'm
Yeah.
just envisioning he's got some mad scientist shit out there and I want to
Well,
go out there now.
yeah. Well, there's all kinds of things that are being tested at the same time, obviously, but we're actually a lot of testing we're doing is with transcritical scrolls. So we've got transcritical scroll condensing units in our facility that were built from our European office. We don't make them here in North America, but we imported these condensing units to understand the dynamics, the controls, how the transcritical scroll value is and how it works and all that kind of stuff, and oil carryover. So we need to test it ourselves. Plus, we designed our own transcritical scroll unit, built it, and run a whole bunch of different tests in different modes. We have what's one mode's called flash tank VI, which is a variable flash tank pressure. And I've heard you talk about this before, Kevin, and Brett, about, the value of possibly having a variable flash tank pressure. So that's one mode of operation. And then there's another mode of operation that you want your flash tank to be steady. Then we'll put an economizer on this thing and we can get you a flash tank that's steady. So those are kind of testing that we're doing right now in understanding the dynamics of oil separation for ourselves. So we run it through different tests, different scenarios.
You said
So
condensing
Andre,
units. Oh, sorry. Go ahead, Gav.
So these condensing units, would this be like a one-offy thing, like for like a restaurant or convenience store, like something smaller, or would this be like handling multiple loads because it's variable speed and it could go up and down?
yes and yes. The I guess the most cost effective way right now for a CO2 condenser unit with one compressor, that scroll can go from 20 hertz to 90 hertz. It's got a really wide range of capacity. So for a small lineup of cases, that makes a whole lot of sense because CO2 units will be more expensive naturally than the HFC unit. But someone that has sustainability goals and net zero goals, they want to go that way. And it's a good way to go. So that's one option, the single compressor. But there's also a lot of interest in, paralleling these, maybe two or three of these things now. Now you've got a mini transcritical scroll pack or a mini booster pack. Now you've got distributed refrigeration from a remodel perspective. It starts to make a lot of sense. We're hearing a lot of buzz about that and the need and want for that in the near future.
I mean, yeah, it seems like a great like application for like convenience stores, like smaller supermarkets where they could, utilize that. Now, are these like 90 bar systems, 120
Oh, yeah.
bar?
Yeah. So the unit that came from Europe was a 90 bar low side suction, and all of the OEMs that we're talking to right now about the transcritical scroll, I mean, they're not playing around. They're designing all these things in 90 bar standstill, low side, and 130 bar on the high side because they know that these things can cycle out for a weekend and they don't want to have to worry about losing the charge. So everybody seems to be looking at that 90 bar low side standstill. Yeah.
See, you said this was a single compressor, and this is a brand new transcritical scroll. So my question is, you said flash tank, so obviously you have the flash tank. So your suction pressure and your flash tank pressure are going to be at two different pressures. So are you telling me there's almost like a vapor injection line on the
Yeah.
scroll? Are you
So
laughing? Am I wrong?
no, you're bang on. If you're familiar with the vapor injected refrigeration scroll that we have with, the port on the side that injects midway through the compression cycle, well, we've taken that and we've applied it to CO2. So instead of using parallel compressor to manage the excess flash gas coming from the tank, that excess flash gas goes into that port and gets digested in the compression. So what it's doing is instead of sending that, of course, through your bypass valve to medium temp suction, increasing all that load, it's doing it midway through the compression. So there's an efficiency gain by doing that.
So how do you? I mean, how is that size then? Like, I mean, is there a standard? I mean, that's gonna get into some engineering, but I mean, is there a standard flash tank load when you're dealing with a convention? Like, let's just say you're dealing with, you know,
Absolutely.
10 tons, 10 tons. If you're dealing with 10
Yeah.
tons, is it always going to be a certain BTUs of that 10 tons that's going to be needed for the flash tank, even in, transcritical and subcritical mode? I mean, obviously, transcritical mode is going to be more, but I'm sorry. Go ahead, talk.
Yeah, no, we have to account for that. So a typical booster system, for example, you may have 45% at your peak condition in the summer, 95-degree gas cooler out. You might have 45% of your compressors running just to manage that flash tank. That bypass mass flow is nearly 50% of your total mass flow for your system. You still have to take that into consideration when selecting that for injection. And it's part of the software, right? You got X amount of here's your gas cooler out temperature. That's going to create, this is the flash tank pressure you want to manage. It's going to create X amount of percentage of flash gas, and you need to bleed X amount off into that compressor, and that compressor needs to be able to handle that load. So it's all calculated in the software.
So
Yeah,
does that
and Brett, yeah, on a single unit, like it wouldn't be as bad. I mean, because if they're designing for 90 bar on the low side, I mean, they're not gonna blow a receiver pressure relief like you would on a rack. Let's say if a flash gas gets a little high and gets up to 600 on the rack, you're popping the relief. If it's running 600 on that, it just kind of is what it is, and it'll come down.
No, you're right. I mean, with the flash tank VI version, with a floating flash tank, we can float that flash tank to nearly 60 bar, say nearly 870 pounds. So we don't get about 58 bar actually. So you can imagine when you're floating to 58 bar, you're not generating much extra flash gas than if if you've got a 45 bar a 30 bar flash tank. That's a big
I mean,
difference.
yeah, that would give you more compressor capacity at the same time because you don't have that load on there. So, I mean, that could be used for peak compressor capacity to give you a little bit more oomph.
do we still have a BGV on the line? Because I mean, if you're not running that compressor if you're running it real fast, so there's not much load because you're still in subcritical, you could actually
Yep.
tend to back that up some. So there's still a bypass gas valve on there.
Correct. And you get to a point where your flash tank gets to a point where you're going to shut it off. It's a solenoid in that bypass line, not the bypass line, in the injection line. It's just a two-way solenoid. So
Really?
when your flash tank gets to a certain point, you turn that solenoid off because you're not generating enough flash gas to do any good. So turn it off and just trim the flash tank with the bypass valve going to suction.
And you're not going to damage the intermediate part of that scroll because you're not feeding it with a cool vapor at that point.
Nope. No, it's been designed to handle that.
Get the hell out.
Yeah.
So, obviously, you're still testing this, but like, what's the ETA to start seeing these scrolls out, these full size scrolls out in like the advancer racks and like other full size racks?
Yeah, it'll be about a year from now because even though there's some European voltages, well, there's one European volt, 450 hertz, not very useful for here in the US, 400 volts at 50 hertz. So we're in the motor development stage here in the US, 208, 230.
Oh no, Andre, I think I lost you. You're paused.
Oh,
No, damn it. Fixing now. Oh, there you go. Got you now.
there
Yeah,
it
sorry
goes.
about that.
I was about to have a car in here. I'm like, this is going so well, and we're getting lots of stuff out, and then all of a sudden,
All right, we lost motor design.
I'm freaking out today because my internet got changed today. So I just upgraded my internet today. Now upgrade, it's debatable. So I'm actually running off my phone because I was freaking out because my home internet's been turning on and off all day and it's brand new. It's supposed to be 3 times the speed. So anyway, I apologize.
No, you're fine. You're fine. We lost you at
Yeah, deal that in a weekly basis anyway.
yeah. Kevin lives up in Indiana, and they don't have internet up there. His kids are up on the roof, covered in tinfoil, getting him a signal. So I get it. Kev, where do we lose him at? I forgot. I was really upset.
Motor design. You guys are redesigning motors for it.
Yeah, that's right. So that's what we're working on right now. developing. The one thing about compressor motors, it's incredibly involved. It's because of the overload protection, and because you guys know that these motors operate at all kinds of different operating points in the envelope, and that thermal overload's got to work perfect at every spot where it could trip. So it's a lot more detailed in developing a motor than just throw a 2.8 volt motor in there and away you go. So it takes about a year of development plus, months of testing on our calorimeter on our test bands. So it'll be about a year before we actually have them out. But that being said, our OEMs are testing the 400-volt 50 hertz version. You want to drive, so we're getting experience with that product, and so are we. So that when the time comes and the motors are available, the OEMs will be ready.
So are these scrolls the you said variable? Are they on a VFD or are they on? Are they digital unloading type?
No, no, this is a BPM motor, so they are on a variable speed from, like I said, 20 to 90 hertz. The maximum capacity is somewhere around 130, 135,000 BTUs at a plus 20 at 90 hertz. To kind of give you an idea the size of these things,
Hmm.
16 cubic inch up to 36 cubic inch. So we're very excited about it.
So and this is just for medium temp, right?
Just for medium temp right now. The team is working on a low temp version, but we're not at the sampling stage yet. So we're focused on medium temp.
Gotcha. Well, I mean, I don't even know how that would work unless you could basically size your low temp load. Oh no, because you'd have to have even more capacity because if the flash tank is basically could be upwards of half of what your load is, right? And that means
Right.
you would need even more load to pull that. So that would be a two compressor system, right?
It's a large compressor. So a lot of pressure to overcome from 200 pounds to possibly 14, 1,500 pounds. 200 pounds at minus 20 to 1,400 pounds. Dead of the summer. That's a lot of lift. It's a lot of stress on bearings and everything else. So it's a special one, that's for sure.
So going to be a two compressor system then?
It could be two compressor or two stage.
Because the only systems I know is what's it Revicold. Revicold is one of the ones that has it's just a two compressor system. And then what was the other one we saw at AHR? Yeah, can't remember that other manufacturer.
The one we couldn't understand. I'm not sure. I don't remember. But yeah, those were two compressor systems.
Okay.
But
And they were using like little fractional horse compressors.
yes, they were
You
like
know,
little Hitachis, like little
yeah,
Hitachis scroll or that screw. They were like mini screws almost.
little rotaries.
Yeah, little rotaries, like the little window
Yeah.
air conditioner one, which surprises
Yeah.
me that those things can handle that.
Well, I
Yeah.
mean, the one compressor is basically, the low temp compressor is going to be the equivalent of what 410A compressor, right?
Yep.
Like, is there much difference, Andre, with the design between a low temp scroll and a 410A compressor? I mean, essentially almost the same compression ratio.
Yeah, the compression ratios are close. The embodiment is the same embodiment per se. Of course, the scroll form is going to be different, and the bearings are going to be slightly different. But from an embodiment and almost the motor, everything is a little bit tweaked, but it's fairly close to a 410A product from a low, I guess,
I
from
mean, Hill's
from
using 14. They're using 410A digitals for all the like low temp stuff. They're using this the 410A like standard digital compressor.
Really?
Yep.
yeah, our ZO is our digital, yeah, low temp version.
Anything else you wanted to bring up with Andre while we have him on the horn, Kev?
Mhm. Trying
Well,
to
I did
think
double
here.
check with the oil. the oil guys, the 68 and 85 for Zero Scrolls.
Yeah.
They are approved for both 68 and 85. You may have mentioned that before, but they are.
Yeah,
Well,
like, it was weird because we talked about it for a little bit, and then we saw the bulletin come out, and but you had said that bulletin had been out for a while. Yeah?
yeah,
Like, about the 68 weight?
yeah, 68 and 85. They're approved for
Yeah.
both. Yeah.
Yeah,
So
we talked. Go ahead, Kev, sorry.
with the higher weight oil, is there more carryover or less carryover when we're running transcritical?
Well, there's no more or less as far as that goes. There's no difference as far as carryover. It's the different viscosity at a specific point.
I'm sorry, what do you mean by that? I'm sorry. You said so the heavier the is it like the heavier the viscosity, the less carryover just because it's a heavier weight
Yeah.
oil,
No,
or how does that work?
it's the same.
No, it's you're
Oh,
the
okay.
same.
That's all I got right now. I'm not.
Andre, is there anything you wanted to talk about before we hit the end button here? Anything you want to bring up? Anything you got going on that you wanted to talk about?
Well, I kind of mentioned it, I think, throughout what's been going on. One of the things that I do see that I suppose from a collaboration perspective, I don't know what you guys are seeing, but the industry is going through an increased amount of collaboration. It seems like at every level, from the contractors to the OEMs to the consulting engineers, even to the end user, with all these refrigerant regulations coming on board, the speed at which new equipment is moving, the sustainability targets that our customers are having, the energy they're trying to reduce, all these things are happening at once very, very quickly. And I get the feeling that customers, the industry as a whole is figuring out that we can't all do this alone. We've got to collaborate more now than we ever have if we collectively want to move forward faster. And I see the next couple of years is not going to slow down. It's going to speed up and increase. So it's a good thing, obviously. More of us are talking, more of us are sharing stories and collaborating on a whole range of topics. So it's kind of cool.
So I mean, I know this isn't a CO2 question, but I mean, what are your thoughts on the tech shortage? I know, you talked to Brian Beitler, and he's really big in trying to get the kids in. He said it's funny. He said he was at a middle school the other day doing a presentation, trying to get people involved with trying to do refrigeration and stuff. And he said he learned two things. He said, one, I need to bring more candy next time. And the second thing he learned was that he needs to be some kind of influencer or whatever, because he said that over there they had a he said the busiest table there was like a YouTube guy that was out there, which I thought was just the funniest thing. So, but I mean, other than trying to get everyone trained up, because I mean, with the tech shortage, guys are jumping ship for a couple of dollars because we're in so high of demand. So, I mean, professionally, I mean, you've been in the industry, quite a while. What are your thoughts?
Well, the biggest challenge is getting new people interested in the trade, which is it's a big challenge to begin with. This, our trade is so small that if your kids aren't coming in because they know you were in, or you've got a cousin or something. So from the school, it's a challenge because they get pushed to go to university instead of, you know, pursuing a vocational school. So that's number one challenge. How do we get more people in there? And I think more of us have to, again, collaborate on ideas and get together as an industry to try to tackle this. And the way the SRC's been trying to work on that. That's the recruitment is one phase. I think the other phase is companies like ours and our competitors have to get better at. I like this. I don't like to use the term plug and play, but you know what I mean is make things easier, auto configurable, and easier to troubleshoot. There'll always be the need for high quality service troubleshooting guys. That's for sure. They will always be there. But the run of the mill things that someone walks into a machine and doesn't know where to start because they're so new is what kind of tools can we provide those those techs that are unfortunately they get thrown out into the middle of a job that they don't have the experience for. We got to be better at providing those tools for them from a equipment supplier perspective. So, and I've been harping on that for years that, we make the equipment. So we need to kind of collectively figure that out. I don't know if that rings a bell with you at all, but that's on my side where I think we can try to help.
Well, I'll give you an example. You hit the nail on the head with, about trying to get more people involved and interested in the trade at a younger age and break the stigma about, you can't make any money doing, one of the vocational trades, which is very incorrect. So
Right.
quick story, I put my daughter on the bus one time and, she comes home later that day. She's like, "Daddy, how comes we can live here?" And she's 12 at the time. Okay. I was like, "What do you mean?" And she's like, "Well, a little boy asked me what you did for a living because he saw that you got in your truck for work after you got me on the bus, and she asked the kid asked my daughter, what does your daddy do for a living? HVAC. Well, you guys don't make enough money to live on this block, and like a 12-year-old didn't come up with that on his own head, right? So that came
Right.
from the parents. So, like, just breaking that stigma of like, this is a great trade to get into. There's tons of potential to make a lot of money. It's all what you put into it, right? I
Yep.
mean, the payback that you get is incredible if you're willing to put the licks in when you're younger, and learn all you can and try to be the best at what you can. It doesn't take entirely much to really be good at this trade as long as you put the work into it.
Absolutely. No, I agree. Yeah, it's a challenge still that we need to overcome for sure.
Um, On that note, Andre, I'm going to thank you very much for coming on here. Kev, is there anything else you want to ask before we let him go?
No, I think we got a pretty good one in. We'll have to have him back on another time.
Definitely, 100%.
Well, appreciate it, guys. It was great meeting you on HR, and thanks for having me on. Appreciate it.
Absolutely, boss. Thank you again. Hey, guys, have a
Take
good
care.
night.